Sorry guys, the battery ran out, or no, not the battery, the memory ran out. So anyways, so it's gonna be, Arduino right there, one of the AC lines on one that, this to the coil, one of the coils, and then the other side of the coil to this. And yeah, that's really it. And I'll have some protection circuit, not even a circuit, just a device across this. From the Arduino, I'll you know what? Well, I don't have any displays or anything, and I don't really want to spend the time doing the display thing, so I'm just gonna have the Arduino communicate with my computer, and then the little shell program or whatever that Arduino the Arduino stuff comes in, where you could print out outputs and inputs and see that stuff. I'll just have a little program there on my computer where I could just type in some temperature, some the rate at which it increases and whatnot, which should be pretty easy. I already can think of something I could do. I could just say, okay, let's say if I want I'm pretty sure in the manual it says maximum 108 degrees Fahrenheit an hour, increasing. So I could just say yeah, 108, there's 60, what is that? We'll just say a degree, let's say a degree and a half. It's a little under, but a degree and a half a minute. So really the thing just has a little timer, and the program, and the thing will just full power, open up the relay, this whole state relay. It'll heat up, the thermocouple will heat up too, and then once the thermocouple reaches a degree and a half, within the minute mark, it'll just turn off until the next minute, and then it'll turn on until it reaches the degree and a half, and then turn off. Pretty much just do that. So yeah, and that's pretty easy to do. So I've done harder programs, whatever, so at least that's what I'd like to think. But anyways, yeah, and then the whole input for the thermocouple, you just make a little circuit with a voltage divider and stuff, and then just reads the voltage. And actually no, I keep on thinking the thermocouple is a resistor, the varies resistance based on temperature, but it just produces some voltage. So I can just read out the voltage straight from there, and you do something with 1024. There's 1024 units, and then you just divide that, or you divide the pretty much the maximum temperature. You either do that, or see, here's the thing. It's pretty straight, but not really. So either I have some function in there that it goes off of, or I just do, well, actually I could have multiple functions, because you can see right there it's almost straight, it increases a little right there. You know, it goes like that. Increase, this is pretty straight, so I might just have multiple functions. Once it reaches a temperature, you know, it's like x is greater than 2. This function, x is less than or equal to 2. This function. You just do that, so yeah, I guess I'll just do that. And yeah, it should be pretty easy. You just have, you know, I don't really know. Anyways, I'll think of it later once I get the parts. I'm gonna actually start developing the program today if I don't have much else to do. Yeah, but I definitely need to research on the protection circuit on that, and definitely need to know like at what voltages too. You don't want it too close, but you also don't want it like, I mean, this thing's up to like 480, so I could just do like anywhere between pretty much like 150 and 480, pretty much, you know, because I mean, yeah, whatever, you guys get it. So I'm getting really excited though, because it's just so simple, but like the functionality and your ability to manipulate it like pretty precisely is just pretty cool. And I can do all this stuff like really cheap, so yeah. Because I watched a video and they had some brand that makes digital Kiln controllers, and it's like $300. You know, obviously that one was probably that one was a lot more you know, be a lot better than mine. But still, I mean, yeah. Oh, another thing I just noticed, I'll definitely actually just hook this thing up to my computer because I need a 5-volt source. So, although I could just, you know, use one of those, put it into that, you know, simple. But I still need a digital display for the readouts and stuff. But it's gonna be awesome. So I'll get you guys later, and I'm gonna go look at some parts. Need a protection circuit, so like a varistor or something, or TVS or something like that. An Arduino. I don't know if I'll get like an Arduino Mega. They're only $10. Arduino Uno. Might just get a small one, easy to place. I think that's really it. Is it? Oh, I need these things, the pupils. And I'm not sure if I'll just leave that there, leave one of them open, or if I should get 3, because they're $10 each. So that's $30 already. But the other stuff's cheap. Arduino under $10, and you know, the voltage protection thing, that's around $5. So you know, we should be right around $50. Makes the whole project $200, you know, with the kiln. But you know, it's definitely like a learning experience, paying for your education, I guess. Alright, audience guys. What's up, guys? So the thermocouple and that, you know, going into an input, an analog input, input pin in the what you call it, the Arduino. It's not gonna be enough voltage, because if you do the math, so I guess it's like a 10-bit, 8-bit system, something like that. So it ends up being like there's like a 1023 like steps that it can sort of divide the voltage into, and divides 5 volts pretty much. So if we do all that, I end up getting for every click or whatever, or for every for every like individual input, like 1 out of 10, 23, it's 5 millivolts. And that's just way not. And this thing's probably just gonna go to like 30 millivolts. So I can't just have like 6 sections. I need a lot better accuracy. So I'm just building a amplifier. I just found one online. I ended up even having the right part, the LM358, I think, something like that. Operational amplifier. So yeah, I'm sort of surprised, but yeah. So I was thinking, I could just do a PCB. I got the materials, done them before, and I almost got it. But you guys see, it just peels off right there. It really sucks. And this is my second one doing it. So screw it. Screw the PCB. I got some scrap, obviously scrap. This, and I'm just gonna wire it. So I could use this as a little guide. That might be good. Let's see. Yeah. So I'll just use this as a guide. I'll probably just break off this, and I made solder paste, and it's pretty cool. I did on here. You guys see? I'm wondering if I should do solder paste, hit it with a heat gun. It's just like really cool, really convenient. Unfortunately, actually, I don't know. It heats up like the whole area, and I'm just afraid that, these things might not do too well like that. But if I take my time, like, I don't want the operational amplifier to break down, but I think I know there's, I think most semiconductors, after like 125 degrees Celsius, they're iffy. So, what is that? I don't really know. I don't really know, actually. I think the alloy, the tin lead, I got that. Because the other stuff doesn't work as well. Tin lead with some rosin paste, works wonders. And yeah, real easy. Because my soldering iron sort of sucks. It really sucks, actually. And you guys could just see how clean that is. Real clean. So it's a little better than soldering iron. So I'll try it. I don't think I have another microchip like that, so let's hope I don't break it. But considering I had that, and it was like new, I think it was from this Radio Shack kit I got back in 4th grade. It's like 6 years ago, over 6 years ago. So they probably have them at Radio Shack. So if I, break it, I could always just get another one at Radio Shack real quick tomorrow, because it's like 11:45 right now. So yeah, but I took a nap, so I'm feeling pretty good. Yeah, anyways, I'm gonna go get the little circuit and I'll be back. Okay guys, I think I have it all set up, so I'm gonna hit it with the heat gun. But you guys, good. Here, I'm just gonna put you guys right over here. I don't know if you guys will be able to see that well, but turn this on, definitely. Maybe put it up a little more. Space is so cluttered, but whatever. Okay. That's not good. Yeah. Let me touch this up with the soldering iron. This is pretty bad. What up, guys? So still haven't kept up to date with the YouTube stuff, but yeah, kept you guys up to date. But yeah, I showed you guys this already, and I don't think I showed you guys the circuitry, the digital circuitry, but it's looking good. It's in the house, so yeah. But so like I'm wondering, not really wondering, I was wondering whether I should convert these little slip over whatever to the ring terminals. You know, I didn't really want to like make any changes to any of this stuff, but yeah, I think I'm gonna have to. It doesn't even matter though, because like if I sell this, they're probably gonna want digital anyways, right? No one really wants to buy cones for this stuff or anything like that. So, but I mean, if I do sell it, I could just they won't know. You know, I mean, I'm only cutting this, putting this on, so it'll be just back to here if I wanted to, you know, get that. And yeah, so no biggie. So yeah, I'm gonna put these on. And there's also like a two thing terminal. Yeah, I guess I'll just cut this one. I'm sorry guys. So I'll just cut this one. And probably put some heat shrink on that, just so it doesn't touch anything. So I'll go do that, and yeah, you guys, when I'm done. Okay guys, I just did these, heat shrink this part, those two, and brought this out. So yeah, it looks, you know, pretty decent. Here's the TVS. It's like the transient voltage suppressor, I think, something like that. It might not even be that, but whatever. Yeah, so right here is the 27X amplifier, pretty much. You just change this is a resistor right here, so you just change that to change the amplification, but or the gain, whatever. But what I was getting, it was around 26, 28 times, you know, what's getting out of here. So you just have to put that into the whole program and stuff. But I certainly want to do this. So I don't know. I guess I could check out the multimeter. I don't know if this is conductive, but I don't think I would want it connected to ground, so I might have to put some padding or something. And I don't want to drill any new holes in here either, so maybe I could just put one of those through either one of those rods or something, and then zip tie it like the other or something. And I don't know where to put this either. I was thinking I could put it, you know, along there or something. It might be good. So yeah, I'll figure that out. But what it's gonna look like is, okay, you got, let's just put this in, sorry, something like that. This is going to be connected to that. Boom. That is going to be connected to one of these, and the other end of this will be connected to that. Super simple wiring. So yeah, guess I'll just try to get the everything sort of in place and stuff. Will that rod go through? Sorry, it's probably a pretty bad video, but doesn't really look like it. So yeah, so I just know something. This actually won't fit. So I guess I gotta do it lengthwise, which might be better. but I'll have to have some padding and stuff like that. So let me go do that. Or nah, let me just go do that. Okay, guys, got it all set in there, and yeah. Hope I did it correctly. Got the board right here, so you know, just gotta plug the thing in. Probably set it right here or something. I don't really know. Or just set it out. I don't really care. But yeah, and then you know, have this. In there. So yeah, we'll be good. Can't finish it today. I'm going to Lake Tahoe tomorrow for a week, so won't be working on this for a week. I might do the program actually. I'll probably do the program over that full week, and then you know, just practice technique for glass blowing. But between here and Lake Tahoe, I feel like I've seen a lot of ceramic stores and stuff, so I'll just try to get 3 of these peephole things, or just a brick. I mean, if they have the nice soft bricks, I could just carve one out. But yeah, do that. I could test it out actually. Yeah, I could test it out, see if it works. Maybe I'll do that. I just gotta make sure nothing's touching, nothing metal's touching. I think it's all good. I'll bring the multimeter out here and stuff, but I'm gonna go eat first. So, see you guys later. Okay. The moment of truth. Got everything set up. Got the program going. Once that thing reaches 0.15, it should turn on. So, and I got that right there. So, yeah, it's getting heated up with a propane torch. And yeah. I hear it. Yep, it works. It works. Man. Let's just try that again. Yep. Okay. So, I need to charge my computer. But yeah, that does work. So, yeah, that's good. Now, yeah, man, that's too scary. I got to develop the program now, and I got to get that pretty much. Everything's pretty much unplugged, so it's pretty much in there with some insulating sort of, you know, peephole thing. The only thing is, you guys see a little metal, like you have the hole right there, the back hole, the smaller, and then there's a little metal thing that sort of actually scrapes it. So, but I mean, this stuff's pretty soft, and it'll probably come with a really soft like cone, so I just have to push it in once and it should be good. But yeah, glad that worked. So yeah, I just gotta do the program now. I don't know if I'll do that today. Maybe. I sort of want something to do while I'm on vacation or while I'm up at Lake Tahoe, because I don't want to get too unmotivated for this. But I mean, I could always just, I don't know. Maybe I'm going tomorrow, so maybe I'll just prepare or something. And then I could even do this in the car because it's Arduino. So yeah, it's gonna be good. And I won't bring the Arduino. Yeah, I'm pretty happy. It's pretty cool. So yeah, I'll look into. Let me just cancel this. Sorry. Yeah, sorry guys. I'll look into how you should like preheat the glass and stuff like that for annealing. Look into that kind of stuff. I'll also look into preheating kilns and stuff like that. Yeah. And sort of just have my program along that. And then since I'm gone for that long, I could get into like really fancy like a command line and start putting in a bunch of numbers and stuff like that, and or type in a command and then it will do this or do that. I mean, that's actually what I should do. So, but I might go even further than that. Yeah, I think that's it. So, it sort of sucks that I'm going for a whole week, but I don't know, I'm sort of excited too, because, it's Lake Tahoe, it's like foresty, whatever, mountains, and, I'm wondering, like, once I get out of high school, if I should just rent an RV or whatever, or not rent, like, get an RV or just a car, and, do stuff like that, sort of road trip and eat fish, just, some odd jobs. I don't know. Anyways, it just seems cool, relaxing, and you're able to really think things through. But yeah. I don't know. Plus I need to get sort of work out a little, so might boost some stuff. But I should probably burn that. Hey, sorry guys. Yeah. So, but definitely the glass blowing too. I gotta get the technique and stuff, and just all the hand movements and whatnot. So I don't really have to even bring like glass rod. I should probably actually bring glass rod, just to get really familiar with the glass, and the type of like bonding and whatnot. Because if you get something slicker, then I noticed with the glass it'll like really track right here, but if I use like something else, like pencils that have the painted pencils, paint over wood pencils, you know. Might go along a little better, and then I'll be too used to that, so yeah. Plus, I mean, maybe the visual aspect of it, and since I'm pretty much just doing two, then that'll help. So yeah, that's that. And I should probably bring the GoPro. Oh, I also want to collect some minerals. That'd be cool, because I got the that sucker, and if I get the glass blowing going, you know, I mean, I've been talking about this and working for it for way too long, you know, and I didn't really think I would get a kiln, but got a kiln. Digitalizing it, you know, made that whole thing right there. I mean, it's coming together, slowly but surely. Stuff hasn't leaked yet, which is good. I can give you guys a little. I haven't powered it, and I think I powered it once in the past 2 weeks. The thing has only been good for like 6 weeks, so you know, that's why it's just hope it doesn't leak, you know. Might play with it a little today. Yeah. Or you know what I might do? I don't know. I don't want to get too caught up into something and forget about that. So yeah. Anyways, another thing I was gonna try out is you know, might change up my diet a little. 'Cause, you know, it sort of goes along with the whole, you know, after high school plans, and in case I want to, you know, not really work as much. Yeah, I mean, I have to save a lot of money, you know, live in my car, whatnot. But I mean, it's not even, it's some of that, but then also being like sort of environmentally friendly and stuff like that. You know, I sort of want to like not eat as much meat and stuff, and go more for like plants and whatnot. Just cause like, you know, I mean, it takes a lot of resources to grow or whatever meat, and then to sort of not great for the environment either. So yeah, sort of cost a little too much. So singing, you know, vegan or whatever. Sorry guys. Maybe like vegan. I don't know, vegetarian. Not like fully vegan or whatever, but like, you know, most of the time. And if when it's just like more convenient to eat meat, I'll eat meat. It wouldn't be bad, you know, to eat meat like that, but to eat it every day. I'm eating like half a pound. I was before like 2 months ago, I was eating like a pound of chicken a day, along with like 8 eggs or something, and some like a cup of yogurt, whatever, 2 glasses of milk. And I mean, it's sort of a lot. It's sort of expensive too. But yeah, it's just not sustainable. So, you know, I moved the chicken down to half a pound. The eggs down just to 3 eggs of 8. So, you know, I'm just, you know, testing it out, seeing how the protein lowering is working, and I don't really see a difference. So I think I'm just gonna go all out and just go with, you know, all that stuff. Plus, like, Uh, take it back. I don't know. Never mind. I was gonna say, maybe just eat more like raw, like not cook as much. Because, you know, if I do live in my car, it's gonna be like hard to cook. And I don't wanna like cook under the radiator or anything like that. And then the solar ovens take a little too much, you know. And then I could connect something up to the, you know, my battery, but I don't know. You know, it'd just be easier to maybe sprout everything and then just eat it raw. That's what I was thinking. I don't think you can really. Like grains, you can't really do that. Beans is sort of like iffy. At least what I read today. And, you know, just the phytic acid, all the anti-nutrients, pretty much just bonding to nutrients. Yeah, so, anyways, I just haven't been doing YouTube too much, so started giving you an overview, which you guys probably don't really care if you're watching this video specifically for my kiln setup and stuff, but that's alright. I could always just cut it out. And yeah, you guys get another look. Pretty cool. Pretty glad that everything works. I don't know what I'll do with this. You got open pads. You guys can see the soldering job. Good enough. Like, who really cares? Doesn't look like there's any cold joints or whatever you call them. Yeah, so everything works, like I said. And I mean, I got even more. I mean, I got like quite a lot of the Arduino. It's actually pretty cool. I got it for like $7. It's Arduino Nano. So yeah, it's small, but I mean, it still has like a bunch of like inputs and outputs and stuff like that. So, and yeah, if I ever wanted to, I could do a lot more with this. I don't know if it will though, because like, yeah, I don't really know. But yeah, it's something I really have to be careful about is when I first heat it up. You know, I haven't heated this up yet. Because I wanted to make this thing digital, and I didn't have any cones. And B, because you gotta be careful with heating it up too fast. You heat it up too fast, the trapped moisture in the bricks will turn into vapor too quickly and start like exploding or like raising the pressure in small pockets in the bricks, and then sort of just exploding, breaking the bricks. So yeah, I gotta do a nice slow roast 2-day. I don't know about 2-day, but nice slow roast at probably 400. I don't know. It's a nice slow roast. Keep all the air ports open. Just really air it out. I just gotta be careful to. Yeah, the thing is, it's not like too accurate. This stuff. So I feel like the thing's gonna. I might just end up making a program that just turns it on. Just make a set program probably. I'll probably just end up doing that. and just having a humongous like while loop or something like that, or for loop or whatever. I don't sort of forget all that stuff, but just have a huge loop of you know, if let's say like I send a command to the thing, then like with that command it triggers a whole while loop that has just you turn it on. I don't really know. Yeah, I think I'll have it like it'll turn on for a set amount of time that I put in there that I just think is right. Turn off, turn on, turn off until, and then like sort of monitor it through this, and you know, like, but like, because at the beginning, when it's only like between 0 and 100, or probably even like 200 degrees Celsius, the thing really doesn't like register too well, and just because it's sort of like inaccurate, or just sort of like the Arduino only goes to the 10 millivolt placing, the 0.00, or no, the 0.01 placing. So you know, if I amplify it, yeah, it's sort of complicated, but I'll explain it. If I amplify it through 27, about like we'll say 25x amplification system, then this, you know, that thing will produce between 0 and 60 millivolts, between like 0 and about like 2200 degrees Fahrenheit. I don't really know. I think it's something like that. So I mean, let's see, at the, oh man, okay, I remember it's like 4 millivolts is pretty good, so we'll just say like 4 millivolts. I sort of forget what I had on when it's boiling water, and that's what we're going to be looking at, boiling water, and what it was below it. But yeah, this is getting a little weird. Never mind. I mean, there's a lot of problems with it, you guys can see, with the baking out of the bricks, and plus like the coils. Thing is, like, if I just have it like until the thing starts registering, the coils are going to be on, you know, until the thing starts registering, and it's going to take a while for the air to like heat up, and then for the metal on here to absorb enough heat to where it's at the same temperature as that. And by that time, the brick that's around the coils and like stuff like that, you know, might be pretty hot enough to like start boiling water. And at that point, you know, that's when pockets of moisture trapped brick, whatever, is going to start exploding. And I don't really want that. So yeah, if I'll look online, definitely see what kind of like the power or like see what kind of temperatures these coils get up to with a certain amount of power and stuff like that, and then just base it off of that. And yeah, that should be good. So I mean, you know, there's a lot of work I could do just for my computer. And that's actually really cool. Like that's like one of the cool things about like all this stuff, like Arduinos and stuff, and microcontrollers. You just have to have, you could do stuff with the hardware, but then also like, you could just lay in your bed and work on it, you don't have to be in the garage or anything, or you could, be on vacation and work on it. So, although you don't really understand it that much, which is why I don't really like using it that much, because I don't really understand how the microcontrollers work, down at the logic level. And then at the logic level, how those stuff work, and at the transistor level, and then at the transistor level, how those work at the like atomic level, got the crystal lattice, the phosphorus doped silicon, and then you got the boron doped, something to do with like, metal oxide, and then attracting electrons. Then they'll make like stuff like that, and that ends up making a MOSFET and stuff like, but I don't really know. So yeah, definitely. And then even at that level, it's like you don't really understand it even then, because how does all the electron stuff work, and the charges, and the mathematics of the charges and stuff. And yeah, it's gonna take a while for me to learn all that, and just what is like force and charge. And I think I'm gonna run out, so I'm gonna run out in like a minute or something like that. So I'll leave you guys with that, and hope this. Yeah, I'll be running out. I'll just do it until this runs out. But you know what? I won't actually, because it might screw up this video. So, adios, guys.